Hi, my name is Wallace Kemke, and I am the president and founder of Pterofin Incorporated, a renewable energy company that is going to be the next generation of wind and hydroelectric energy. Here to save our planet. You're welcome. We design products that mimic a bird's wing or a fish's fin. They oscillate back and forth as opposed to a turbine blade which rotates. The key advantages to a Pterofin over a turbine is essentially just that. It's an oscillating wing that doesn't experience overuse, overspin, catastrophic failure, which is why you don't see turbines in residential, commercial, or industrial areas where there is property that can be damaged or lives that can be lost. So I am bringing to the world a renewable energy technology that can be deployed on homes, on businesses, in industries that need electricity and can do so without hurting themselves or the environment. Back in 2006, I had an idea to reverse engineer the rear fin of a fish. As it essentially wags back and forth, it would turn a generator to create hydroelectricity. And several prototypes later, I came up with a more complex design, and it worked, but it wasn't efficient. So I rebuilt again and again until finally I came up with a prototype that operated extremely efficiently. It was a bit complex, and I was able to test it in front of a fan, and I was surprised how much movement it demonstrated in front of very low wind speeds. So I filed a patent, and I started a team of students that competed in a couple of different competitions, and we built a prototype that we're able to test at a wind tunnel, and we were able to demonstrate how efficient the technology is, especially at low wind speeds. So we continued to build prototype after prototype, and we pumped water, we generated electricity, and we refined the technology to something that was extremely simple. The students graduated and went on to do other things, yet I continued to build prototype after prototype, eventually working with another team of high school students where we built an extra large scale single wing Pterofin that was installed not in the ideal area, but we were able to attach a pump. That is a diaphragm made of rubber and a simple lever arm that pulled on it and was able to pump water at a pretty good head pressure or depth, I guess. So this would be ideal for groundwater in a remote location where one would need clean drinking water. So I refined the technology a bit more to create something that was made entirely out of bamboo. This was a fairly crude prototype that was actually not attached to anything, so it didn't have any resistance. But I did learn from it, understanding the basics of what makes the wing oscillate, and created something that was 100% PVC and pretty much junk. The wing itself is bamboo and saran wrap. There is a couple of junk plastic bearings in there, and this was not actually attached to anything as well as far as the power that's being driven from the wind, so it was able to oscillate freely. However, this prototype did have a magnet that was raised and lowered on a lever arm that passed through some copper coil and generated electricity. That is a tiny LED light you can see, powered 100% by the magnet moving up and down. And there's a golf ball counterweight on the back and an old hairband or headband as the kind of the elastic little leash, I guess you can call it. But this prototype was able to pitch back in high winds, so it didn't get destroyed, and it was probably cost about $1.50 to make. This prototype right here is a similar prototype, except it is designed to generate electricity. There are a series of miter gears and clutch bearings that ratchet on a drive shaft that is geared up to spin a flywheel, aka frisbee, which below is attached to a generator. You can't see it, but this was able to produce a pretty good amount of power at low wind speeds. Some time passed, and I was able to put together another team of students, and we built this prototype and was able to test it at the Kirsten Wind Tunnel at the University of Washington. And this prototype essentially demonstrated a wing oscillating back and forth, spinning a generator, and at a specific point in wind speed, the wing stopped oscillating, and this is to protect it from overuse or catastrophic failure that a turbine would experience in higher winds. So I built this prototype in my garage the following year and was able to test it on my shed. I did learn a thing or two about the control and oscillating motion, and was able to build this larger prototype that I installed on my house and took to a maker fair, actually. There is a larger generator with a flywheel, and the wing is a composite that is extremely strong. The timing for the control system to make the wing oscillate back and forth was a bit crude, and I refined it sometime later to operate a bit more smoothly. But I was able to take home the blue ribbon for the Maker of Merit. So after building nearly 20 prototypes, some worked great, others we learned a lot from, I started to realize that utilizing Pterofin technology in the wind had a pretty steep learning curve. There are a lot of variables, including wind speed and survivability in a windstorm, being left out in the environment, rain, looking at rust, waterproofing, any of the electrical components. So I started to dabble in hydroelectricity again. Rewind the clock back to 2011, when I first put together a team of students. We also built a hydroelectric prototype that sat on the water and was able to produce a good amount of electricity. The gear ratio wasn't ideal, but we were able to demonstrate how it would work sitting on a stream or a river. The next year, we built another prototype, and this sat underwater, and it generated hydroelectricity, which would be ideal for tidal currents, oceanic currents, rivers, or streams. And just last year, I actually designed this prototype. It is about the size of a car. It has a 10-foot wing that reaches down into the water, and the whole thing is anchored to a dock or a buoy or something underwater where it can sit in a moving current and the wing can oscillate back and forth. The whole thing is made of styrofoam pontoons and 2x4s. There is a generator, which is the red cylinder that you see, and a blue flywheel that maintains the rotational momentum of the oscillating motion that generates a significant amount of electricity. This prototype would cost anywhere between $150 and $200 to build. Extremely easy to manufacture and mass produce. The control arm that you see here just falls due to gravity based on the position of the wing, and it is what controls the angle of attack of the wing that oscillates back and forth. extremely simple. There are a few miter gears and a few bearings in some brackets, and it just utilizes gravity to change the angle of attack and continue its oscillating motion. This is a wind energy prototype that I would love to build as well. It is exactly like the last hydroelectric prototype that I built, except upside down and mounted on a pole. It is a simple 2x4 frame, and the wing would be styrofoam like the last prototype I made, with a composite shell around it, almost like a surfboard. The counterweight, that is the control arm that changes the angle of attack, is exactly like the last prototype. However, instead of it using gravity like previous prototypes I've made, it uses rotational momentum to change the angle of attack of the wing. So as the wing oscillates back and forth, the counterweight continues to swing, and that is what changes the angle of attack. So please check out Pterofin.com, and I'm excited to share with you the next generation of renewable energy.